Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome to the Solidity Smart Contract courses. In these courses, I teach people how to write smart contracts for different use cases. Previously, we've focused on NFT smart contracts, especially doing a reveal of your NFT. Well, we are going to today update that reveal smart contract, that NFT smart contract, to make it a pre-sale as well. We need to implement a pre-sale mechanism that will take in a whitelisted addresses for people to be able to mint before it's released to the public. That's what we're going to be doing. So to get started and to follow along, go to the GitHub page, go to this repo, and then you can go to smart contract over there. Once you're in here, click on the smart contract. In the NFT folder, you'll find a list of files like these. Like I mentioned before, these full ones I always just update for myself just to keep a full contract available. But what I want you to focus on is actually this reveal. We are going to be adding a pre-sale to it. So click on the reveal nft.sol. Once you're on this file, you can scroll all the way to the bottom, copy everything from this last curly brace, just make sure you include it, all the way here to the top where the comment starts. Now head back to remix.ethereum.org, which is our online Solidity compiler. Very cool. Once you open Remix, you can go ahead and start a new workspace. So you click on that plus icon at the top. I'm just going to keep to the generic workspace, and there we see our 3 files. I'm going to go ahead and actually delete these 3 files and delete them like so. I'm going to delete this artifact, and I'm just going to right click on the contracts folder and create a new file. This file I'm going to call NFT Presale.sol, like so. Once I have that ready, I can now take everything that I've copied and paste it inside the smart contract. You can see that all the dependencies are busy installing, and this is because we have these 2 imports over here. So just let it do its thing, basically. And then once it's done, you'll see that it doesn't start populating here anymore, and you can just close these folders, so it's nice and neat. Now we can start focusing on how we're going to add this pre-sale kind of mechanism. We already have a whitelisted mapping in here, but this whitelisted mapping is used for a different purpose. It is used to kind of say that if someone is whitelisted, they also don't have to pay for the minting, which is not our use case, and you also have to add the user's addresses one by one. We want a way where we can take an array, add it to the smart contract, and then actually have those people mint way before anyone else, and also have a minting limit. And I'll show you how to do that next. Let's get to the alterations we are going to make to the smart contract in order for our whitelisted members to be able to mint before the public. We need a way to switch it on and off. We need a way to go about it in a nice way. So I'm going to show you how we can do that. Now, like I mentioned, this whitelisted mapping was there to actually facilitate adding one by one addresses, and a mapping is good for that, to check if they are whitelisted, and if they were, then they don't pay any gas fees. This was mainly due to if you were working in a team and you want your team to also be able to mint some of the NFTs for free, but they do still pay the gas fees, then we go about it like this. We also had this mint function over here, which calls our mint function down here, this one. And it mints 20 NFTs to the owner's address, which we're going to take out now, but you can probably put it back if you want to. I just want to clean this up so that we start off with the necessary things that we need, and also so you understand what we are doing. If you don't understand Solidity to this point that we are working with it, please go ahead and do the Solidity Basics course on my YouTube channel. Let's clean this code up. All right, so we're going to get rid of this mapping over there. We do not need the whitelisted, so I'm going to remove that. We're also going to remove mint. So we're only basically doing that to just not overcomplicate the project. Then we're going to actually take out this if statement wrapping around the value required to buy an NFT. We're leaving it in for the owner. We don't want the owner to pay when they mint, because sometimes you want to mint and actually give it away to people. So the owner will only have to be paying the gas fees. Next, what we want to do is go down and we're going to leave everything as it is. There is these whitelisted functions already, but I think we're going to remove one of them. I want to keep the other one and I'm going to repurpose it. So I think we can already start to repurpose it, and let's change this function into something, call it whitelist, maybe users. Okay, whitelist users probably sounds still fine. Yeah, so we want to whitelist the users, and then we need a list of addresses. Now, for those of you who've watched the Solidity Basics course, you know that arrays and complex data structures need to be kind of a type of memory. We need to save it somewhere. Now, if you pass in an array to a function, you have to make it of type call data. All right. We're going to say these are going to be our users list that we're going to pass in. It's only going to be available to the owner and it's going to be public. And now we need to kind of assign this to something. I'm going to remove this just for a second and let's go back up to our variables. Right at the top here, we need to now declare a new variable, and we're actually going to declare an array. Okay. So how do we do that? We don't want to declare an array there. We want to say this needs to be an array of addresses. So we're going to say, make this an address array. This is also going to be public. Remember, when you use these contracts in your own code, please review it yourself. Please make sure you've checked the logic yourselves. But also, I'm mentioning this because I always make my variables public so I can read it and actually show it in the tutorial. But sometimes you don't want it to be public. Just keep that in mind. Anyway, then we're going to make this and say this should be the whitelisted users, whitelisted maybe addresses. Let's do whitelisted addresses for now, and this is going to be a dynamic array. We want to now take this whitelisted addresses and go all the way down to that function that we've created. And this is the function that will actually assign the new array of addresses to this variable. So firstly, what if this variable included some addresses before? We want to remove it from the array. And how do we do that? Well, we can use the delete keyword in Solidity, and then we just simply put that variable. That's a way to clear out an array. Next, we're going to take that same variable and simply assign it to our new users. Like so. Perfect. We've basically done the first part of adding our user list to the smart contract. Next, let's scroll up to the very top again to where our variables are sitting. We will need a Boolean value to actually explicitly say if this program or this contract should take the whitelisted addresses into consideration. So let's make this a public Boolean, which is a true or a false value. And here we're going to say that this would be our only, maybe our only whitelisted, I don't know. Okay, maybe we should call it only whitelisted. All right, that's perfectly fine. And we are going to initialize this to actually be true from the start. Now, the reason for this is so that we can actually kick off this smart contract just by having the allowed addresses to start minting. You don't want to start with this to be false, otherwise we're going to run into problems where as soon as you mint or as soon as you create your smart contract, there might be a hacker that sits and waits for you and then goes and mints secretively one before you get to turn it off. So let's do this from the start. We're going to set the only whitelisted to true, meaning that we have to check this first. While we are here, I might as well teach you Solidity best practices. We need to always try and keep the same data structures kind of next to each other. There's a random string variable now here, which is the not revealed URI, which we used from the previous example. I'm just going to cut that out and place it just above this where the integers start. All right. This means that my strings will all be defined here, my uints here, my booleans, and my more complex data structures below. If you kind of group your variables, it makes it easier for the Solidity compile to compile, and it uses less byte size, I believe. So that's why it's considered to be a best practice. All right, perfect. Now that we have this, let's go and actually check up on our whitelisted list, and also if this contract should check for them. Where can we do this? Well, the point of entry into this contract, and only for the sale, is the mint function. This mint function is a payable function, and we'll need to adapt it in some way for it to kind of work to our use case. The first thing that I want to remove is the fact that we can mint to someone else. The reason for that is because we are going to also implement later on the business rule, right, of kind of saying that a user can only mint 3 NFTs to their address. So that's why we can't allow them to mint for anyone else. So I'm going to take this 2 out, and wherever the 2 has been used, such as here, we need to now change this into the message.sender, meaning the person who is kicked off this transaction, okay? And that's simply what we're going to be doing there. The other cleanup that we're going to do is we're going to remove this require paused one level up, one line up to there. The reason for this is so that, I'm just going to structure it a little bit better. The reason for that is because when the contract is paused, we don't even want to start with this function. We simply want to return. And that's why we're going to move is paused, the require statement, one level higher. All right. Next, we can now simply go and check if the users are whitelisted, and also if this contract should first consider only whitelisted addresses. So what you want to do to achieve that is actually inside the if statement where we check if the sender is not the owner. Remember, this if check will kick off for anyone else other than the owner. We want to do another if check, and this time we want to check if the whitelisted variable boolean is true. So meaning this one over here, we want to check if this is actually now true. Why is that? In the conditional of the if statement, we can just say if it's true. I'm typing it out like this to make it explicit for you guys. But in this case, it means that the program first has to go and execute whatever is in between these curly brackets. That's why when we've turned this boolean on, it means that our pre-sale is in action. As soon as we turn this boolean off, we will then be able to have anyone mint outside of the whitelisted addresses. Okay, and that's why we're putting it in another if statement. We are going to leave this a require statement for the cost outside of this, because if the pre-sale has ended, we still want this functionality to kick off. What we do need in here though is another require statement. We're going to put a require statement in here and say that we need to check for a user. So now we need to check, because we know that we need to check for whitelisted users. But how do we check a whitelisted user out of that array? Well, firstly, we need to loop over it. And the best way of doing that is to create a separate function. Let's go and create a isWhitelisted function to loop over the array. Okay, so let's make some space right underneath the mint function. I'm going to create another function by defining the function keyword first, and then let's call this function isWhitelisted, right, like that, okay? IsWhitelisted will take in an address, which we are going to define as a user. It's going to be public, and we're going to make this function a view, and it's going to return a Boolean. Why does it need to return a Boolean? Well, Because we are using it here in our require statement, a require statement takes a boolean, and if something is false, it will fail and revert, and it will also then leave a message if you put a message, optional message in there, but it requires a boolean. So we're going to call this function inside there. So let me just show you why. I'm going to put this function in there in the require. I'm going to pass a user. So what we need to do now is we need to pass the user message dot sender. Okay, and because this is going to return to us a boolean, I'm going to explicitly check for it. So this is going to either return true or false. And maybe if you want to add a optional message, you can type in user is not whitelisted, right? And we can just leave that in there for now, so you can see how to append a require statement with an optional message if it fails. This message will only show in the console if it fails, and that's what you need to also remember from this. But let's leave it like that so we can test it on a later stage, but we still need to complete the functionality of the isWhitelisted function. So for completing this function, we need a for loop, and a for loop structure is very simple. It has a for in front of it, and then it has brackets and curly braces. In the for, we need to put in our statement for how many times it's going to loop. We can use a uint, and we can assign this to a variable called I and assign it to the value 0. Then we can say as long as I is less than the whitelisted addresses. Now, whitelisted addresses, remember, is our array that we declared at the top. And we can specify to get a number of how many times it should iterate. We can say that this should be the whitelisted addresses length. That's how many times it should iterate. And then we're going to increase our I variable, meaning that it's going to come in here, it's going to see it's 0, saying if I is less than this length of this whole array, it's going to go in this loop, it's going to do its thing, it's going to come back, and then it's also going to increment right after. All right. Next, we want to put an if statement inside of the loop, and the reason for that is we literally need to check if the whitelisted I, meaning that every time it loops, this variable will increment to 0, 1, 2, 3, 4, 5. And we want to basically check the location of that array's address and match it and see if there's a user assigned already. And if this user coming back from this, so this statement over here will actually return an address. And if this address is equal to our user that we are passing in, then obviously we want to return true, right? So because we found someone, we found a whitelisted address. If nothing is found, we still need to return down here, but this time we're going to return false. If the return statement is called, this will actually exit the function and stop execution of this function. So that's why it's perfect as it is right here. And now we can continue with our if statement over here just to do the rest of the checks. And the only thing that we need to do now is actually kind of consider if someone can actually still mint, meaning that we know that they are a whitelisted user, so we're continuing with our program, and now we need to see if they are under the limit of the NFT per address limit, if I can put it like that. How can we implement this? Well, let's go create another variable at the top. Scrolling all the way to the top, let's go and implement our new integer. We're also going to make this a UN256. It probably doesn't have to be that big at all. But I'm going to keep to this because I'm still teaching everyone Solidity so that you don't get too confused with different sizes of integers. We're going to call this variable maybe NFT per address. How does that sound? NFT per address limit. Okay. So this is going to be the NFT per address limit. I'm going to make it 3 for now to say that each whitelisted address will only be able to mint 3 NFTs. Now, we have to follow best practices here. And at the moment, we won't be able to really set our NFT per limit. If this is set in the contract, we can't change it. And we also need a way of changing our only whitelisted Boolean variable to switch off the pre-sale after the sale has ended, right? Or after we tell it to end. So let's go down and see how we can achieve this. Firstly, we can go here to the top and basically copy and paste this set cost function. Because it's the same function that we'll be using for setting a new integer, we can actually just change a few things. For instance, we can just change the limit that it takes in to say we're going to work with a limit. And this we can just simply say this is going to be the set NFT per address limit. I know these functions are very explicit and long, but sometimes it's better and you just have to work with the trade-offs on using longer function names and to readability. But at least this is more explanatory to do it like this. We want to then go ahead and set the NFT per address limit to the new limit. This will allow us to update that limit if we want to extend it after our pre-sale. So let's say that our pre-sale has ended, and now we can simply make this limit 10,000 if we want to. We know that the address can hold enough NFTs, basically. Perfect. Next, let's go cater for if we want to switch off the actual smart contract pre-sale method. So we can simply duplicate this pause function, and the reason why is because it also changes a Boolean variable. Now the Boolean variables it can also be called state, and maybe all I'm going to do now is say set only this is going to be set only whitelisted. That sounds fine. Set only whitelisted, right? It means that when we tick this function, it's going to pass in a Boolean, and we're going to set the Boolean to the only whitelisted Boolean over there at the top, meaning that only whitelisted addresses will be able to now buy. All right. I'm going to do one more change. I'm going to cut this out and maybe move it below the pause, so it's part of this function structure, at least here at the top a little bit over there, just grouping some stuff. And then we are ready. So now what we want to do is actually have a check for the limit, okay? So now we have a limit at the top that we know that has been set. So how would we implement it, making sure that someone that is a part of this whitelisted array can't mint more than their allowance? Well, that's very simple. All we need to do is let's declare a UN256 and let's call it owner. So we're going to call this owner token count. How about owner token count? Then we're going to refer to a token as an NFT, basically, because that's what an NFT is. So once we have that, we're going to call the inheritance function called balance of. Balance of is the ERC 721 underlying function that will give us the balance of this address. And the address that we want to check is the message.sender, because that's the address that we're working with currently. Once we have that, all it takes is to put in a simple require statement. And over here, we can now say the owner of the tokens, right? The token count should be at least less than the NFT per address limit, meaning that this owner's count should be less than 3, basically. We don't say less or equal than, because the thing is when it's less or equal than, you can still mint 1 extra 1. We want it to be just below it, so you can still do 1 mint. And that's basically all that's needed for this to be completed. Now that we have this functionality in place, we have a way of updating our address. We have a way of updating our Boolean to see if this contract should indeed be in pre-sale mode or not. We also have a way to limit a user and set that limit. And this is all basically that a pre-sale entails. Now, I want you to also understand that there's numerous ways of handling pre-sales. There's not only this way. This is one way, but this is a way that you guys can go and experiment with and see if it works out for you. Anyway, that being said, it's time to do a test. so that you can see how to properly initialize this contract. So we're now ready to test our smart contract, and I just want to mention something very key to this is if we go and grab a bunch of addresses here on the side, I just want to show you how you will pass in the address list of your whitelisted members. So maybe you take it off a CSV file, whatever it might be, it needs to be in this format. It needs to be an array structure with strings inside, and inside the string, obviously the address. Okay, so I'm going to just copy a bunch of addresses here just so that we have some structure to follow when we actually test our smart contract just now. Okay, so I'm going to do that, and maybe I'll just put these below each other like so. All right, so I'm just going to copy one or two more, and then we get to test our smart contract. I'm very excited for this, and I think you guys are going to use this quite a bit. Please just make sure to do what I'm doing so that you make sure that you have tested your smart contracts. Remember, once this is on the blockchain, it's there forever, and if you have made a mistake, you're going to need to redeploy or find some way that you can fix it off chain. So let's go ahead and do the test. Next, what you'll need to do is make sure you are on the deploy and run section. You have a virtual machine selected, doesn't matter which one, and then on your contracts, just select the NFT Presale contract that we've just created, and then we need to fill in some parameters. Now, I'm going to call this the nerdy test. And for my symbol, it's going to be NT. Then for the initial base URI, remember this is your base that you're going to get from either IPFS or your server. So this will be something like HTTPS and then / like a bunch of stuff. So I'm just going to say example.com /. The one below is the one that we discussed in the previous video where we do the reveal. So this one would probably be reveal, I don't know, something like that. These are just examples. Please don't put these in, it won't work. You'll need your own URIs. Okay, you can test with these. So next what we need to do is say transact. Let's make sure that we are on the top account just for us to easily know that that is the owner. I'm going to do a transaction and it is successful. Now let's go here down to this contract and let's see. Let's try and mint immediately and see what happens if we mint one to the owner's address. We have now this mint function, and you can see that it doesn't take an address anymore. It only takes in a value. I'm going to mint 2 and see if it's successful, and indeed it was. We can verify that by going all the way to the bottom and clicking on total supply, and there it is. Our URIs, we can test if it's working, and we can see that this contract is still not revealed yet because it's giving us the revealed URI back. Just on a side note, if you wanted to reveal your smart contract, you have to be on the owner's address. You click that, and after you've clicked the reveal and you call it again, it changes into the actual revealed data, the real metadata. But anyway, we can see that our symbol works, all these things, but now we've got this extra, not the paused one, right? So paused is false currently. Just want to show you what will happen if we turn this to true. So if I go up and I turn this to true, not even the owner will be able to mint. So if I click transact, it should break down here. And there we go, it broke because it's paused. So I need to have paused set to false if anyone wants to mint some of these NFTs. They are minted another 2 again. So now our total supply should be 4. The next thing that I want to show you is actually the balance of. If we take the address of this user, so I'm going to copy the owner's address now, and I paste it in here. This will work with any user. This is basically what we are doing to check if the user has enough or minted under the limit. This does not count for the owner, but I'll show you in a use case where it works now. Next, let's go and have a look at when someone tries to mint, that's not the owner. So I'm going to change this address to this address, and then I'm simply going to try and mint. I'm going to try and mint 1, and our ether that we need to pass is about 0.05. Now, I'm not going to pass that exactly. I'm just going to pass in 1 ether, but just to give it enough value. But you'll see that this still fails. And why is that? There you can see that it says user is not whitelisted. Now let's go ahead and add the whitelisted addresses. So I'm going to take this array, copy it, go all the way down to this function where it says whitelist users. I'm going to paste that in, and I'm going to call it. It's going to fail because I'm not on my owner's account. So go to the owner's account and call it. Now we have a whitelisted list. To test this out, we can now simply switch back to the account that didn't work before. Again, give it 1 ether because we just want to have some value. And then when we transact, it mints. We can do this again and again. Let's do this again. And let's do it one more time. And let's do it one more time. And then you can see it fails. Why does it fail? Well, the reason why it fails is because if we copy this user's account now, and we go all the way down to the balance of, and we paste it, we can see that this user now has 3 NFTs. They can't mint anymore. They can mint more if we actually set that initial limit and we up it. So let's go here and see. Set NFT limit per address. If we make the limit 10 and we go to our owner's address again, and we go and execute this, and we go and switch back to that user, and we keep on minting again, this should now be successful. And there we go. Now we can see that this owner also has 4, and he can go up to 10. That is basically how it works. Now, I want to show you that if we choose a number that's not whitelisted, 1 down here, and we do the same and we try to mint, it will simply just fail. Why? Because the user is not whitelisted, and also because we have the only whitelist boolean set to true, right? We need to turn that off. So let's go and turn that off. So how do we do that? We can go to the only whitelisted, and we set false. So this is what you'll do if you want to have your pre-sale end. So I'm going to switch to the account owner and then execute false. It's executed, and now if I go and switch back to that user that couldn't mint because he wasn't part of the whitelisted addresses, if we go and we try and mint again, it succeeds. The limit will also now not apply, right? Because that limit was set in this if statement only. So let's go to the if statement. There it is. So now your whitelisted addresses don't count anymore after you've set only whitelisted to false, because now it's a normal contract that everyone can buy. I really hope that this helped you guys. And if you liked this video, please let me know in the comments, and also go and join our 2 servers. We now have a nice Discord server and a channel where a lot of support is given to people who want it and also want assistance, as well as a cool Telegram channel. Go and follow us, and the links to those channels are in the description and also on the GitHub repos, and I'll check you around.